Hey everybody, welcome back to another Creo video. This is Carter, and today we're going to be talking about the icosahedron, the 20-sided dice, as it were. This is what it looks like when it's fully completed, and we'll be taking it step by step and showing you how to create this. So the first thing that we're going to do is we're going to want to create kind of this base plate, which is basically half of an icosahedron. And then we'll just use an assembly to flip it upside down, rotate it, and then attach it back to itself to create the completed part. You may notice that this toolbar up here may look slightly different than what you're used to. You may or may not have done an assembly before. So this is part, and this is assembly, and you can see there's some differences, and we'll get there. So let's start with figuring out how to create this. Let's go ahead and create a new file. Call it icosahedron. And I'm going to go ahead and turn all my planes back on. Make sure that I have shading with edges, and we're good to go. So, first thing that we want to do is take a look at a drawing. You can see right here that we have this triangle followed by 3 other triangles, which are all at a slight angle. So let's start by creating that first base triangle. This will be the base off of which we build everything else. So let's go to extrude, and for this I'm going to select the top plane and we'll orient like that. And then I'll just use a line chain and draw a triangle. Just like that. Doesn't have to be perfect. So let's go ahead and get some dimensions in here. These are all 60 degrees since it's an equilateral triangle. And the length doesn't matter, it just determines the size. I'm going to pick an arbitrary number, let's say 100. That looks nice. And then this isn't as big of a deal, but it will make it a little bit nicer if this triangle is centered on our point of origin where these 2 blue lines cross. So to do that, I'm just going to get 2 lines like this, and I could do some math to figure this out. There's kind of a neat trick where if you draw 2 lines like this and go to the center of the opposite, they'll actually intersect in the center. And if I do a third one, it'll also intersect. So this will be the center of the triangle. And I can actually turn these into construction lines by selecting them, right-clicking, and then selecting this option, which is construction, which means I can use them as references, but they don't actually divide up my drawing. So you can see that once I turn both of them back into construction lines, that my purple shading came back. And then I can put a point on the intersection. You can say I can use these as references, and then I can just constrain this point to the point of origin like this. And now my triangle is in the center. So that's just a useful trick. And let's go ahead and extrude this. And since we're going to be building from the top, and each of these base plates, have thickness, I'm going to bring it down like this so that my plane is on top. You can see my plane goes to the top, and then it goes down below the plane. And we'll make this an arbitrary thickness, doesn't matter. 5 is a nice thickness. And we'll go ahead and OK that. So this is going to be the base, and we're going to build our 3 triangles on angles on these edges like this. So to extrude, we need to have a plane, but none of these planes that we have right now will work. I can't select this edge to extrude and then extrude at some random angle. The best way to do this is to create a plane. So what we can do is we can select this edge right here, and you can see that it gives us this plane which is at some angle, but it doesn't quite know what angle it's at yet. And you can see that I can't just make a plane because make a plane, I either need 3 points or 2 lines. Okay? So what I'm going to do is I'm going to hold down Control and I'm going to select this top surface. And you can see now it uses that as a reference to figure out what angle it's going to put this plane at. So this is what's called the internal angle. So if I go back to my completed one, if I turn off planes first, if I were to look on the inside, so let's take a look at this plate right here. I'm going to put it on the bottom, and you can see that this triangle is at an angle to it. So that angle goes from here to here. That's called the internal angle, and it's the same for every single one of these triangles. You may have heard of internal angles maybe in some of your math classes. So the internal angle for an icosahedron, we're given that right here, you can also Google it, is 138.1896. 138.1896. There we go. And notice that I'm measuring from this edge as opposed to this edge. This edge is on the outside, and notice if I were to measure from here to here, everything would be offset by a distance of 5. It would be 5 lower than it needs to be. So you want it to be this edge right here, which is going to be the internal edge. This is going to be the inside. This will be the outside. All right, so we have our plane. So we can extrude on that now. And let's turn the planes back on. All right, and we want to draw a triangle. So I'm going to come over here, select references, and make this edge a reference. And again, I'm selecting this edge because this is the edge that is going to be internal to the figure. So if I come back here, you'll notice, let me turn off my planes again. You'll notice that if I zoom in, I have 2 edges. The edge that runs here, where everything connects, and the edge that runs here, which just kind of extrudes outward, kind of gives the shape some thickness. So we need to be careful about which edge we're selecting. So in this case, since this is the internal and this is the external, we want to select this edge right here. Okay, so let's go ahead and draw another triangle. And as we get more triangles on this will make more sense. Then throw that in there and give this a length of 100. And Creo was just nice and went ahead and gave me an internal dimension of 60. No, it did not. It was constraining horizontal, so you would want to check that. Let's go ahead and delete the horizontal constraint and make this 60. Okay, 101 angle is all you need to make the triangle. So we'll go ahead and OK that. And once again, give this a thickness of 5. All right, so this is what we have so far. So hopefully now you can begin to see why selecting the correct edge is important. If we didn't, then this edge would be constrained to this edge right here, and these plates would be offset by a distance of 5. If that doesn't make sense, then just make sure that you have this shape at this point. If you don't, you can always pause, back up, and see where you went wrong. Okay, so you should have this, and this angle from here to here should be 138.1896. Okay, let me turn my planes back on. From here, I could do this 2 more times, or I could just select this and then go to pattern, and I want to pattern by axis, and we're going to pattern about this y-axis. So you can see that it's going to give me 4 right now. I can change that to 3 because I have 3 sides of the triangle. And the angle between each one is going to go a full circle, which is 360 degrees. And we want to split that into 3 equal segments, like this. So you can see it's going to be 120. So we'll have our first one here, our second one on this side, and our third one on this side. 1, 2, and 3. So we OK that. And you can see it pops those in for us. All right. So we go back to our picture, let's go ahead and zoom in to make it a little bit easier to see. You can see that if this is our base plate, so we're kind of looking at this from maybe the bottom. So this is our base plate. We've created this, and we've also created this, this, and this. Agreed? You see we have this, just like that. Okay, that right there is this right here. So the next parts that we need to create are going to be this triangle right here and this triangle right here. And then we'll pattern both of those around to the other two sides. So the way we're going to do that is we're going to treat this as if it were a base plate, and once again create a plane at an angle, just like we did a few steps ago. So we'll do plane. We'll select this edge. Remember, it's this edge because this is the internal edge. This is the external edge. And then hold down Control and select this. Now, here you need to be careful because Creo gives us the angle from this side, from the outside coming in, rather than from the inside going out. So if you think about what a straight line is 180 degrees, right? And we know that the angle from here to here is 138.1896. Then what's left is just 180 minus that. So 180 minus 138.1896. And the reason that we're doing a different angle here is because whereas before our angle was measuring on this side, now it's measuring on this side. Okay? If it helps, you can stop and draw just a straight line like this, and then draw a line at an angle, and you can see it'll give you two different angles, bigger one and the smaller one. Okay? Here, Creo decided to give us the smaller one, and so we have to do 180 minus instead of just entering in the larger angle. All right, so we get 41.8. We'll go ahead and OK that, and then we'll extrude on that plane. Right, and you can see this time it gives us a view with the internal edge, so we'll use that as a reference. We'll draw a line and just make a rough triangle. You always want to double check to make sure that your internal angle is 60 and your length is 100. So we OK that. Make sure that it's extruding on the correct side, so it's going to be going out like this for a distance of 5. And we OK that. So it's getting a bit cluttered, so I'm going to turn off my plane so you can see what we've done. So that's our base plate in green. And these three triangles are the original three triangles that we added on. So we just added on one more triangle like this. And we're going to pattern it around 3 times, one here, just like we did before. So we select our latest triangle, extrude 3. We're going to pattern, and we're going to go ahead and select axis. We may be able to use reference, but I'll just go ahead and do axis. And we'll select the y-axis, because that's the vertical axis. Think of it like the pole around which you are rotating. We want to put on 3 of these with an angle of 360 divided by 3, because we want to go a full circle. I'm going to space them evenly out. All right, so we OK that, and we get this kind of wonky looking shape. All right, last thing to do is to fill in the remaining triangle, which is going to be the triangle filling in right here. All right, and the plane for this one's pretty easy because remember, and you can go back and you rewind the video. But remember earlier I said that you can do a plane using either 3 points or 2 lines. Well, here we have 2 lines. So if you select this edge and then control this edge, You can see that the OK option is already highlighted, and that's because Creo knows that these two lines, there's only one plane that goes to them. So we OK that. We have our plane, so go ahead and extrude, orient to sketch view, and then make sure that you draw using these internal edges, not these external edges. We'll put both of those as a reference. And then draw our triangle like this. And since we're just filling in space, that's going to be 60. And this is going to be 100. And you can see that's true. So let's OK that. Give this a thickness of 5. Make sure that it's going in the right direction. We don't want it 5 in, we want it 5 going out in this direction. Okay, OK that. And then pattern it one last time. Pattern by axis. Select the y-axis. 3, 120. We're just repeating what we did for the first 3 steps. Okay, let's turn off our planes. Let's go ahead and save this. And you can see that we have half of an icosahedron. Okay, and here it's going to be a good idea to stop and check your vertices where these all come together. Make sure that you don't have any gap. Make sure that nothing looks funny, that they all have this nice kind of 5-star shape. If they all do, then you know that you're in a good spot and you should be good to go on to the next step, which it looks like we are. Alrighty, so the next step is going to create a new file, and this time, instead of part, we're going to select assembly. Now you may or may not have done an assembly before, but I'll go ahead and explain what it is. Let's go ahead and name this icosahedron assembly. And what an assembly is it allows you to come over here and assemble parts that you've already made. So you can see that I have an icosahedron part. I have my example assembly and my example part here just below. So I'm going to import an icosahedron by selecting it and clicking open. And I get this window right here. So I have placement. Creo wants to know, where do you want to place this? So it's purple, which means I can move it. So I can move it like this. I can rotate it. Okay. And it's asking me to select any reference for auto type constraining. What it wants to know is, where do you want me to put this? So I have all these different options, but the one we're interested in is default. Okay, if I select default, you can see now this says fully constrained, and it snaps in to the point of origin right here. Let me turn off planes so you can see it a bit better. So it says fully constrained. That means I can no longer move it around. You can think of it like I need some sort of anchor off of which I can build everything else. So we'll go ahead and OK that. All right, and now what we can do is we can assemble and bring in another one as a duplicate. And what we want to do is we want to attach this one to this one. So here's how we're going to go about doing that. You can go ahead and let's click on placement to close that out. And when you're in assembly, it can be very difficult to see where the piece is in 3 dimensions because your screen is only 2 dimensional. So when you import it in, before you go moving it around, I would highly recommend that you go to your saved orientations and that you select one of these 3 options, top, right, or front. I'm going to select front. And what this does is it reduces the view to 2 dimensions. So now I'm looking at just up and down, left and right. I can't move the part closer to me or further away from me. And then I can rotate it. and move it up again. Okay, and just make sure my mic's still going. Okay, and then I'm going to go to my right side view and make sure that it's properly oriented like this. Then I'm going to go to my top view and I'm going to rotate it 1 over like this. And you can see now it kind of looks like it's opening up and I just need to push it down. I'm going to keep a little bit of space in between so that I can have some view so I can see what I'm selecting. And then I'm going to come back over here and select placement. And you can see it wants constraint type. It's just automatic for now. That's okay. So we'll come down here and select edge. And what this allows me to do is I can select any edge. So I'm going to select this edge right here. And you can see now that I have this dotted line. So it's basically wanting to know, where do you want me to put this edge? And I want to snap that edge into here. And you can see that it's not letting me select edge. So I just come down here and filter out edge. And then I select just like that. And you can see it says partially constrained. Okay. Now, it may be a little bit helpful if we kind of open it up a little bit so that we can see what we're doing. You can see it's constrained these two edges together, but we need to tell it to do one more edge in order for it to be fully constrained. You can see it still only says partially. So we'll come down here, filter out edge, and we'll do this one. Remember, these are all going to be internal because those are the ones that are touching. And this one right here. And we'll need to filter out edge one more time. Just like that. And you can see now my part turns orange and it says fully constrained. So we click, oops, I think we might have done something wrong. Let's open this back up again and see if we can figure out what went wrong. Let's remove that one. I think I might have selected the wrong edge. Let's see here. Can we, okay. So let's go ahead and remove that. There we go. And we'll do front. Try and get this reoriented back to the way it was supposed to be. All right, coincidence. And we'll filter out edge, that edge to that edge. And then again, that edge. There we go. Okay, so sometimes Creo will flip the part around, so you just have to be mindful of that. If you do an assembly and you try and constrain something and it's not working, there are a number of reasons why that might be the case. You might be selecting the wrong edge, your constraint type might be incorrect, or your part might not be correct. If the angles of this part are not correct, if you maybe entered in an incorrect angle, then you won't be able to get all the edges to mesh properly, and Creo will realize that and it will refuse to allow you to properly constrain it. So if it says invalid constraint, then there's a high chance that this part is incorrect and you'll need to go back and double check that. So it's fully constrained. We'll go ahead and OK that. And just double check to make sure that all of our vertices look okay, which they do. Everything's looking good, so we'll Control D that. All right, don't forget to save your work, And that is how you create the icosahedron.